friend Terry Krieg to address you today on nuclear power. Terry has for years studied this subject, which is so important in this country, and has delivered many lectures, including on the ABC Ockham's razor, 3 times and one a couple to come. And he's an adamant proponent of nuclear power, as you will hear, and the advantages of nuclear power to Australia in terms of helping our carbon deposits in the atmosphere, of the pollution which inherently results from coal, and last but by no means least, reinforcing the lack of progress in the nuclear area of technology and the contribution of it to our national intellectual capital bank. Terry, please come up. I'll introduce you to the centre.
Thank you, John. Good afternoon, ladies and gentlemen. I don't know about you, but many years of still raging debate about whether or not man is the major cause of the current global warming has got my head spinning. The anthropogenic global warming believers say the science is settled. The sceptics say it isn't. And in late 2010, Bill Jones, the lead author of the IPCC 2007 report, agreed that there have been no statistically warming since 1995, despite about 8% more CO2 in the atmosphere. And in a presentation to the British House of Commons on February 22 this year, Richard Lindsay, Professor of Meteorology at the Massachusetts Institute of Technology, said, and I quote, "Briefly, I will simply try to clarify what the debate over climate change is really about. It most certainly is not about whether climate is changing. It always is. It is not about whether CO2 is increasing. It clearly is. It's not about whether the increase in CO2 by itself will lead to some warming. It should. The debate is simply over the matter of how much warming the increase in CO2 can lead to, and the connection of such warming to the innumerable claimed catastrophes. The evidence is that the increase in CO2 will lead to very little warming, and the connection of this minimal warming, or even significant warming, to the purported catastrophes. And the evidence is that the increase in CO2 will lead to very little warming. The arguments on which the catastrophic claims are made are extremely weak and commonly acknowledged as such. They are sometimes overtly dishonest. Now, in June this year, the AGW chief proponent, James Hansen of NASA, announced that AGW is definitely with us and it's worse than we thought. The CSIRO and the Bureau of Meteorology in Australia picked up on this and agreed with Hansen in their report handed down to the government. It was what the government wanted to hear and helped shore up their position as they prepared to introduce the carbon dioxide tax. Leading Australian denier, Professor Bob Carter, noted that there was nothing new in the report, but just a recycling of old news. Personally, I've read and heard enough from both the warmists and the deniers over many years to satisfy myself that humankind has had minimal effect on the current warming, and the catastrophic AGW, as enunciated by the believers, is a hoax. That said, and for whatever reason, man-made climate change or not, most developed countries want to reduce their CO2 emissions. And Australia certainly wants to do that. But of most concern to me in this whole energy issue is what major type of electricity generation Australia will adopt to ensure a secure, emissions-free baseload energy supply. Most unwisely, in my view, our government is pinning its hopes on the inadequate and very expensive renewables, the sun and the wind, still developing technologies, carbon capture and storage and geothermal, and gas, a fossil fuel. Around the world, these measures have proved very costly and largely ineffective in reducing emissions. I believe Australia should start developing its enormous uranium reserves for our own future domestic energy supplies. And here are my reasons. Currently around the world, the sun and the wind contribute just 2% of world energy total. Germany, during 2007-8, gave solar subsidies of $4.3 billion and they got 0.7% of their energy for that. They are clearly deluding themselves with what they think the renewables will deliver. With wind power, the Danish experience is instructive. They've got the most expensive power in the EU, have been unable to reduce their emissions, have stopped building wind farms, and last year closed 5 wind turbine manufacturing plants with a loss of 3,000 jobs. And a respected United Kingdom economist, Professor Gordon Hughes, has indicated that government subsidies for wind over the next 8 years will cost £124 billion. And he blames green-fixated politicians for this. Meanwhile, here in South Australia, we're going for wind big time. Advocates of wind power are guilty of exaggeration and omissions when claiming what the wind can deliver. They never tell us the capacity and load factors. And around the world, the capacity factor averages about 25%. In other words, divide what is the installed capacity stated by 4 for what you'll actually get. Wind always needs backup support for when it's not blowing. In South Australia, we're going to use gas, a fossil fuel, as backup. We'll have 2 different sources to guarantee our supplies. That seems wasteful and irresponsible to me. Why not use one safe, concentrated, emissions-free form like nuclear? And in other late 2010 moves around the world, Spain has slashed payouts to wind projects by 35% and denied support for solar thermal projects. France has put a cap on the amount of solar that can be built. United States state regulators in Florida, Idaho, Kentucky, Rhode Island and Virginia have cancelled or delayed renewable energy contracts. Gas will be a major baseload source, but it's a fossil fuel. It gives 40% of the emissions of coal. In contrast, Olympic dam uranium alone, used in future integrated fast reactors, could power the entire planet for tens of thousands of years with no emissions. Well, what should we do in Australia? We need to invest in affordable, low emissions technologies like nuclear power. The fact is, for the next 50 years, there is not a hint of anything on the horizon that can be harnessed at the scale required. In February 2010, in Australia and in a paper, Australia and the Nuclear Fuel Cycle, by Keith Alder, who was the former chair of Lucas Heights, and John Reynolds, the executive director of the Victorian Chamber of Mines, noted, and I quote, "Nuclear offers immediately electricity supply that is reliable and continuous, cleaner and safer than others, generally competitive and alleviates CO2 emissions. With advances in fast neutron reactor technology and the capability to breed fuel, it should become the world's major energy source for a long period. Australia should now position itself to benefit to a much greater degree from its massive uranium resources through active participation in the rapidly expanding nuclear fuel cycle industry. We should not forego the opportunities it offers and simply remain a supplier of the basic raw material for this very important global industry, and that's yellow cane, which I've been carrying around for 31 years since coming back from Canada. That's the basic raw material for nuclear power. Uranium oxide comes from Canada. But the thought of nuclear power scares the daylights out of many people, and I want to now overturn some of the myths perpetuated by these people. Myths that you've probably heard many times. How often have you heard myth 1? There's no safe level of exposure to nuclear radiation. That assertion is really quite silly, for we're all subjected to radiation continuously from our surroundings, buildings, food and each other. It's called background radiation and varies from place to place. A place in the Ramsar has got levels 50 times the average. People adapt to it with no real effects. And studies in the United States, in Canada, Taiwan and Lucas Heights in Australia have shown that chronic low-level radiation stimulates the immune system and can affect DNA repair. The Lucas Heights study showed the workers there had a lower incidence of cancer and cardiovascular disease than the general New South Wales population. Myth 2. No nuclear reactor has been safely decommissioned, and who pays the bill? That's not true. So far, 70 reactors, research reactors and fuel site facilities have been retired. Many have been completely dismantled and the site restored to greenfield status. Decommissioning costs have fallen to about 2% of the total cost of electricity generation and are fully included in the tariffs paid by consumers. Nuclear power production is the only industry on the planet that takes full financial and physical responsibility for the disposal and clean-up of all of its operating and decommissioning costs. Number 3, there's no safe way to dispose of nuclear waste. Nuclear waste disposal has never been a technological problem, but a political one. I'll expand on that in the next section. Number 4, the number of deaths from the Chernobyl accident will number in the tens of thousands. Well, reading from the United Nations Scientific Committee a report on the effects of atomic radiation to the UN General Assembly in 2000, this is what the Chernobyl accident caused. Deaths of 30 workers, high radiation doses to 600 emergency personnel, with 134 experiencing acute radiation sickness, 100 of whom had ongoing health impairment. It placed an increased risk of non-fatal thyroid cancer, especially in children at the time. No evidence of major impacts on public health caused by exposure to ionising radiation, and no increase in overall cancer incidence or mortality that could be associated with radiation exposure, and no increased risk of leukemia, and no increase in birth defects. And later studies by Hansen showed that the Chernobyl disaster caused little risk to the population, and their most up-to-date estimate of radiation doses received by the inhabitants in the fallout zone at between 0.47 and 3.2 millisieverts per year. Both of those figures are lower than natural background radiation in many regions of the world. This is a beauty. Number 5. Plutonium is the most toxic substance known to mankind. No, it isn't. As far as radioactive elements go, plutonium is not even in the top 10. Isotopes of radium are 100 times more toxic. Actinium-227 is 16 times as toxic, and all lead-210 compounds are twice as toxic. And talking of toxic elements, plutonium is hardly in the running. In the Handbook of Toxicology of Metals, it doesn't rate a mention except in passing with the entry of uranium. In 1975, Ralph Nader, you know that name, made the absurd claim, later echoed by Helen Caldicott, you also know that name, made the absurd claim that 1 pound of plutonium is enough to induce lung cancer in every person on Earth. An American health physics expert, Professor Bernard Cohen, who died in April this year, aged 87, called Nader's claim fictional nonsense, and he challenged Nader that he, Cohen, would eat as much plutonium as Nader would eat pure caffeine. After 35 years, Nader had still not taken up the challenge. Cohen, an expert in risk analysis, also affirmed that, quote, there is no direct or epidemiological evidence that the toxicity of plutonium has ever caused a human death anywhere in the world. Myth number 6. Nuclear power stations are not covered by insurance. Yes, they are. They have to be. Nuclear power plant operators are liable for damage caused regardless of fault. They are required to take third-party liability, and cross-boundary consequences of a nuclear accident are covered by a national and international liability regime. In 2006, a broker responsible for a nuclear insurance pool said, and I quote, "It's wrong that insurers will not touch nuclear power stations. In fact, wherever they are available to private sector insurers, Western design reactors are sought after business because of their high engineering and risk management standards." Number 7, nuclear energy is not the answer to global warming. Well, if greenhouse gases, including CO2, are the cause, then nuclear power generation emitting no CO2 will play a major role in coping with the problem. Many leading world environmentalists are calling for increased nuclear power as the only realistic alternative to fossil fuel. And Patrick Moore, the founding chairman of Greenpeace, has said, and I quote, "Nuclear energy is the only non-greenhouse emitting power source that can effectively replace fossil fuels and satisfy global demand." And so, in my view, ladies and gentlemen, every aspect of nuclear power has been demonised by the anti-nuclear ideologues who will never be persuaded by fact or reason. They don't bother with research, have a complete disregard for logic, and are generally unwilling to engage in civil discussion. Their actions have effectively delayed the growth of nuclear power and have ensured greater world use of fossil fuels, especially coal. Unwittingly, they've contributed more than anyone to the greenhouse problem the world now faces. These people have been wrong-headed in their opposition to nuclear power, should hang their collective heads in shame and apologise to the world, as indeed a couple of them have done recently. Now, as I promised, I was going to give you some of the truth about nuclear power, about nuclear waste. Nuclear waste disposal has been handled safely and securely ever since nuclear power was first generated in the late 1950s. Hundreds of workers have handled it on a daily basis with never any adverse effects on their health. And I believe there's an enormous environmental and economic opportunity awaiting Australia were we to take responsibility for some, perhaps all, of the world's nuclear waste. Here are my reasons, based on 14 years' research. Currently around the world, there are about 280,000 tonnes of high-level waste stored in facilities attached to power stations. This waste has come from 440 reactors in 33 countries over the last 50 years. Within 10 years, there will be 48 countries generating power from 550 plus reactors. How is the waste handled? Well, on exit from the reactor, spent fuel rods are suspended in cooling ponds under several metres of water. I saw some in Canada in 1981. They remain there for 3 years and are then placed in above-ground cool air storage, where they remain for about 30 years, by which time they are ready for deep burial in a suitable site. Current storage is achieved on-site, safely, where the power is generated. Since the early 60s, high-level nuclear materials have been moved across the countryside, through cities and over the oceans, with never an incident which leaked nuclear materials into the environment. Purpose-built ships with double-walled hulls, twin engines, twin navigation systems and special hold flooding capabilities in case of fire have been plying the oceans between Europe and Japan since the early 60s. The waste is in a sparingly soluble solid ceramic form, held in stainless steel drums, which are placed in cast iron transport casks with 30 centimetre thick walls and weighing 100 tonnes. In 1984, a test demonstrating their durability was carried out in the United Kingdom. A cask was placed across a straight stretch of railway track. A locomotive and 2 cars were cranked up to 160 kilometres an hour and were slammed into the cast. The loco and the cars disintegrated. The cast remained intact with a 1% drop in the pressure inside the cast. And they are very robust containers, and they protect the waste from outside forces and the people outside from radiological effects. But what if a load of waste was sunk during a journey across the oceans? Well, you've got to sink the ship first. That would be pretty difficult. So it has to be scuttled and sent to the bottom. The cast iron transport cask has to be broken open. The stainless steel drums have to be ruptured, thus exposing the waste to the seawater. The waste will slowly dissolve, be dispersed by tides and currents, and gradually those 5 to 15 tonnes of waste uranium will be added to the 4.5 billion tonnes of uranium in the world's oceans. The Japanese have already successfully extracted uranium from seawater. The sea could be an important source of uranium for them in the future, for their power reactors, which have started to come back online following the Fukushima tsunami. For many years now, the International Atomic Energy Agency has wanted to get the waste out of surface storage and into a more environmentally sustainable storage method. And deep burial is their preferred option. And over 20 years ago, the IAEA established the site criteria for safe permanent disposal of the waste. They demanded simple and stable geology, flat topography and a stable arid climate, low permeability host rock, old saline groundwater of no stock or human value, a thick layer of host rock to house the waste, and a low population density and no resource conflicts. And having established the criteria, they went looking around the world for suitable sites. They found about 4. Most of them are in the southern hemisphere. The one that's viewed as the best is in South Australia and Western Australia. It's called the Officer Basin. And my brother, among other geologists, worked on that for 30 odd years in showing the geological characteristics. The burial site would need to be about 1 kilometre square for surface infrastructure to receive the waste, to take it underground, and ships bringing the waste from around the world would dock at a purpose-built small port on the South Australian far west coast, Fowler's Bay. The discharged waste would be carried on a purpose-built railway or road to an officer basin site about 250 kilometres inland. At the site, a shaft or decline to an appropriate impermeable layer about 500 metres below the surface would be needed. A series of tunnels drilled by a full-face boring machine to minimise rock disturbance could radiate from a central chamber. The waste in drums is placed on cradles, moved into the tunnel and backfilled. The nuclear waste will have been isolated from the environment forever and will never require further human intervention. It has been returned to the Earth's crust, whence it came, and is looked after by the geology forever. It will never harm anyone or anything, ever. So in my opinion, Australia should offer the world the Officer Basin for the development of an international nuclear waste repository for the final disposal of what will be an increasingly small volume of waste. Australia would operate a vital world asset for which the world would pay us handsomely. The economics of the repository, done by Access Economics in 1998, suggested a 40-year life, $200 billion industry, which would create 20,000 infrastructure development jobs, 2,500 operational jobs, and taxes and royalties of $2.5 billion a year. Australia would take its rightful place as a leader in the growing world nuclear power generating industry. And we'd also capture the moral high ground on the question of nuclear waste disposal. I believe the state government and BHP Billiton ought to put in place a 25 to 30 year infrastructure development plan. There's a little bit I wanted to add there, but I'll see that John's hovering. I will conclude by saying the following. This is a summary and a final urging for us to get serious about including nuclear power. World primary energy supply is mostly fossil fuels, coal, oil and gas. They emit CO2, and world fossil fuel has grown 28% between 2000 and 2010. Similar future growth is likely. The Copenhagen Accord called for global emissions reduction of 80% CO2 by 2050. Australia's got a similar target. How are we going to, if global energy use how are we going to do it if global energy use will increase by 50% by 2050 due to population and economic growth in developing countries? It seems impossible to reduce the use of carbon by over 80% over a few decades by a regulation that would have to be enforceable worldwide. So, what are our options to replace fossil fuel energy for transport, industry, services and electricity? Well, primary energy used for electricity generation shows the following percentages of total. Fossil fuel, world 66, Australia 92. Hydro, world 17, Australia 7. Renewables, world 2, Australia 1. Nuclear, world 15, Australia 0. Of all of the countless applications for electricity, we need a base load supply to keep them all going. What's base load? Well, it has to be continuous, reliable and adequate. The renewables, wind and solar are not suitable for base load. They're intermittent and large-scale storage of them is rarely possible. Renewables require backup, which means there has to be extra generation investment to maintain supply. Base load can be reliably provided by coal, gas, hydro, geothermal, they've got problems, and nuclear, and that's available. Nuclear has been in use for over 50 years, supplies power for 31 countries, produces no emissions. Australia is one of the few Western developed countries not using nuclear, and we're the only G20 nation without it. Why so? Fear and politics. And safety, of course, is the big barrier in many cases. There's only been one accident, Chernobyl, which caused fatalities. 3 Mile Island caused no fatalities. Fukushima, despite what you read, there's been no fatalities due to radiation at Fukushima. Fact. And of course, it supplies power to 31 countries, as I already mentioned. My conclusion. So, should we develop nuclear in Australia? Well, if we're concerned about CO2 emissions, nuclear is the only available option to replace carbon for baseload. But at present, there's no bipartisan support for nuclear in Australia. There's much misinformation, perceived political risk, and no serious discussion since the Howard government's reports. But the question should surely be, why are 31 countries using it and another 17 countries proposing to do so? There seems to be strong growth ahead. Lots of countries are building nuclear reactors now. We should add Australia to the list of nuclear nations, and we need urgently bipartisan support from Labor and the Coalition. They've got to stop using the issue to wedge each other and do something good for the nation together for a change. And once they've come to their senses and declared for nuclear power, we've got to expedite the following. 1, we've got to remove all of the legal prohibitions. 2, we've got to establish a regulatory framework. 3, we've got to master the technology. And 4, we've got to plan at least one unit. If we don't plan a reactor in the next 10 years, Australia will be rightly regarded as technologically backward and irrelevant. Thanks for listening.
Thanks, Terry. That was a riveting talk, and we're very grateful that we were able to provide a talk like that to our only nuclear physicist, John Hansen. And just reflecting on that little bag of yellow cake, when I picked Terry up this morning, he told me he had 8 grandchildren. He's been carrying it around for 30 years. Yeah. Yes. It didn't do anything but productivity.
If you accidentally swallowed some, the worst will happen, you might get diarrhea.
And Terry, keep writing speeches. Thank you.